Okay, this is the video over finding the volume of cones. And the volume of cones, here's the formula for it. It is actually going to look very similar to the volume of a pyramid, which we have already done. It is capital base times height, and once again it goes to a point, so it's divided by 3. And the reason that we have a capital B for base is because our base needs to first be calculated. So the base of a cone is a circle, and we haven't done a lot this year with circles like you have in the past, so it should be a little familiar, but new to us this year. So circular bases are pi r squared. So instead of this capital B, I'm going to be substituting it for pi r squared. So one of the things I want you to remember is you're going to have to use the order of operations. So I kind of hate that it's pi before r squared, because I want you to do the radius and square it first, because order of operations tells us to square something before we go back and multiply it by something else. So in my head, it's radius squared times pi, but I'm sure you've heard it pi r squared more often. So the formula we're going to use is radius squared times pi times the height of our cone, and then divided by 3 because it comes to a point. We have not done much with cylinders this year, but if we were to have a straight cylinder, it would just be radius squared times pi, which is the base, times the height, and you don't divide it by 3. So a cone, since it goes to a point, you divide by 3. So if we took a cone and poured all of its contents into a cylinder that had the same height and the same circular base, it would only fill it 1/3 full, because a cone comes to 1/3, comes to a point. Okay, so let's do example 1. Our radius, just quick reminder, radius is only halfway across the circle. Okay, if it gives you the whole diameter, you will have to cut it in half to find the r. The radius is only half. So in this case, it gives us the radius, which is 2. So we're going to do, let me write the formula out here for you again so you can see it. So we're going to do pi r squared times height divided by 3. So our radius is 2. So instead of r for radius, I'm going to put 2 squared times pi. Okay, times the height, which the height, it tells us right here, is 8. So that's going to be our 8, and then we're going to divide the whole thing by 3. So I'm going to do 2 squared first, because we're going to do exponents first. So 2 squared, if you didn't know where your squared button is, mine is right here. So let me clear the whole thing and do it again. I would push 2 squared, or if you want, you can do 2 times 2. That's the same thing. Times, I'm going to use my pi button. I know it says round to the nearest tenth, so I'm just going to show you where on my calculator my pi button is right here. So I'm going to do times pi button, and that will calculate pi, times the height, which remember is 8, equals, and then I'm going to divide it by 3 because it goes to a point. So we're going to round to the nearest tenth, so it's going to stay 33.5. So this is 33.5 cubic inches. Once again, volume is always in cubes, cubic inches, cubic whatever, units. And that's it. That's all there is to it. So here's an example of one that it gave us the whole diameter is 8. So if it gives us the whole diameter is 8, we only need to come up with the radius part of it, which would be half of it. So if the whole thing is 8, I only need 4. So I want to do 4 squared times pi times my height, which is 9, divided by 3. All right, so in your calculator, I'm going to do 4 squared times pi button times 9 equals, divided by 3 equals 150 point, that 9's going to bump my 7 up to an 8. So 150.8 cubic feet. Okay, this is actually very easy. So I'm just going to continue working through the next 2 examples with you, and then you're going to have some to try on your own. For her geography project, Karen built a clay model of a volcano in the shape of a cone. So let's just say here's her volcano, and it's in the shape of a cone. Her model has a diameter of 12, so that's the whole way across is 12. So I only need a radius, so I only want to look at the part that is halfway across, so I only want 6. So I'm going to do 6 squared times pi. I didn't hear her say the height yet. A diameter of 12 and a height of 8. So the height is 8. and then we'll divide by 3. Find the volume to the nearest tenth. So this one says use 3.14 for pi, so maybe instead of the pi button I'll actually type in 3.14 because it wants us to be that picky. So 6 squared times 3.14, I won't use the pi button this time, times 8 equals, divided by 3 equals 301.44. So she will need 301.44. Oh, round to the nearest tenth. The 4 will not bump it up to another 4. So 301.4, and this is cubic inches. All right, let's look at this last one. It says Gretchen made a paper cone to hold a gift for a friend. So I'm assuming it's something like this way. The paper cone was 15 inches high, so the height is 15 inches. Okay, and it had a radius, good, it's only telling us the radius is 3 because that's what we use the radius. Find the volume to the nearest tenth, use 3.14. So we're going to do radius squared times not pi this time, but 3.14 times the height, which is 15, divide the whole thing by 3. All right, so here we go. So we've got 3 squared times, they want me to use 3.14 for pi, times 15 equals, divided by 3 equals 141.3, and that's already to the nearest tenths place, so we're good here. 141.3 inches cubed.